Tired of solving really complicated integrals the normal way? Don't know what to do when you see something confusing in an integral? Ready to switch things up and try something new? Or maybe you're just a math nerd who just loves to learn new things. That's cool too. Then the method of solving an integral with substitution is for you. Welcome to Midnight Math with Alexandra, and today we're going to be talking about solving integration with substitution. But before we get started, you need to know two things. The first one is that integration by substitution undoes the chain rule. And the second thing is that solving or evaluating an integral with substitution only works if you see a function being multiplied by its derivative. So let's look at this problem. And at first it may look a little complicated, but don't get intimidated. This is why we have substitution. So first thing we have to do is make sure that we can actually use substitution on this integral. So a big thing that we are looking for when we are trying to use substitution is the chain rule. And as we see right here, the chain rule is being used because 2x is the derivative of x squared, which is exactly what we need to know that we can use substitution to solve this integral. So now that we know that we can use substitution, let's do it. So the most commonly used variable in substitution is u, and I'm going to use that for this example, but you can use really any variable you wish to. So for this integral, our u would be the x squared because it's the inside function. Replacing this x squared doesn't really do much, so what else can we do? Well, we see that there's more to this equation. So let's simplify it even further. Let's use a du, and this du, as we see here, is the 2x multiplied the dx. So now we've translated this super difficult integral into a more simple one, and it's easier to tackle. But wait, have we really translated this integral yet? The answer is no. We left out a really important step that you have to do to make substitution viable. We forgot to translate our limits. You always have to remember to translate your original limits into limits in terms of u. So even though we translated the rest of our integral into terms of u, we never ever can forget the limits too. And it's actually quite simple to do this. All you have to do is plug in the original limits into the function of u. So for this particular integral, it's actually quite simple, and the limits don't change at all because the limits of the original one are from 1 to 0, which means that the translated one would be u equals 1 squared to u equals 0 squared. So again, it would be from 1 to 0. But it's really important to translate them no matter what, because if this integral was more complicated, for example, if the limits were from 2 to 0, the translated integral would then be from 4 to 0. So that would completely change the integral, and it makes it really important to always translate your limits as well as the rest of your integral when you're using substitution. So now we have successfully translated this integral into substitution by using substitution. What you really have to do now is solve it like any other integral through antiderivatives. Antiderivative of sine of u is negative cosine of u. And to solve this integral, we have to evaluate it at its limits, and its limits are from 1 to 0. And for this, we know this because of the translated limits. So, just turns out to be this, negative cosine of 1 minus negative cosine of 0, which is the same thing as negative cosine of 1 plus cosine of 0 because of that double negative. And bam, there you go, you got your answer. It's pretty simple, right? All you did was took your super complicated integral, and then you used substitution, you translated its limits, and you made it in terms of u, and then you just solved it like any other integral. Super easy, you got it. Just one last important thing to note is that you do not have to use substitution only on definite integrals. You can also use it on indefinite integrals. The only thing different would be that you don't evaluate at limits. Just like how we've been solving any other indefinite integral, you just get a function as your answer instead of a numerical value. So for this example, our answer would be negative cosine of u plus c. Do not forget that plus c, really important.